So I would start with a few questions. Have you ever received spam into your inbox? Yes, most of you, certainly. Have you ever received a phishing email? Some of you, okay. And what do you think? Is this a phishing email or legitimate message? Yes, this is phishing campaign. And when you click in on internet banking, it will show this page. It's easy to recognize that this is phishing, right? There is strange URL, but actually many people, many customers fulfill this form and provide the credentials. But it is not always such easy to recognize fraud or fraudulent pages or phishing pages. Sometimes there is legitimate like name like this one. Do you know what is wrong with this name? This red one? There is switching only 2 characters. So for ordinary person, it looks like our page, george.sk. This is how it follows this phishing campaign. Attackers also gain SMS authentication code from our clients, and then they use this code to log into our page. This is how this typical phishing scenario looks like in wall picture. It will end with account takeover and maybe also fraudulent transactions from client's account. So the question is how we can detect such account takeover. It's not so easy, but we can do it. First, we can simply use some rules, like if many customers come from same IP address in short time, this could be maybe attacker, or different rules we can engage and combine together to create detections. This is easy to deploy, and it works from first day. It's good, it's easy, you only need domain knowledge experts like me, and it works usually. But issue of this approach is too many false positives. There is like 100% of false positives, so so analysts have a lot of work, and it can't be managed in daily life. Also, issue is the speed of adoption of such approach, because every time there is new attack, you have to create new rules, and in the end you will end up with a bunch of rules which are hard to understand, and you are lost. What else you can do is engage machine learning. This should speed up adoption and lead to less false positives. So which algorithm to use? It is tempting to address this issue with classical algorithms like neural networks, decision trees, or support vector machines. These are classification algorithms which need a lot of data, and they can learn from data. But in this case, it will not work. Why? Because we have a lot of transactions and logins, but only few frauds. There is a huge imbalance between these two, fraud and not fraud data. What else we can try? We can try anomaly detection, for example. In this approach, we usually study behavior of normal user or standard user or every user, and then detect anomalies or so-called outliers. So regarding this approach, there are following important questions. Which features are important? How should we profile such normal behavior, what is the important, what to store, what data, what kind of algorithms should be used, and how should the model looks like. These are important questions, and we can answer them only if we build anomaly detection framework. What does it mean? We have to have a lot of data, which have to be put in the data mining. We need some domain knowledge to create profiles of user behavior. Then these profiles have to be put in the model as a features. We have to choose right models or test a lot of models to choose one which perform the best. This is the theory how to do it, and what we find out that basically we need to transfer data into information. What kind of information? For example, what is the usual location of the user? How often he travel, where he travel, when he usually log into to his account, when he usually pay, what average sum he usually pay, what is his spending patterns, and a lot of other data like what device user uses, what browser or operation system, etc., etc. More and more data we need to analyze user behavior and create the model according this data to stop frauds. So anomaly detection usually help us with attacks like account takeover, but there are many more attacks on clients we have to fight with. For example, home frauds. This is really hard task because usually in home frauds, family members make transactions, so it's not so easy. They are on same location, same PC, but they stole the credentials from their members of family. Or, for example, push attacks. These attacks are based on social engineering, where the attackers try to force people to sign a transaction themselves. So it is, from perspective of bank, it's usual transaction from the user, and it's pretty hard to detect this was the attack. But there are ways how to do it. There are ways how to analyze also behavior of user and distinguish between anomalies in user's own behavior, like behavioral biometry, how users click, how the users uses his device, or type on keyboard, keystrokes, or mouse movements. All of this can be analyzed and further recognized as unusual. For this, we need really specialists for this field of machine learning and anomaly detection, and this is hard to find such people. From my experience, previous generation of mine were people from police or intelligence services. My generation, we are the guys from the IT, with IT background in cryptography, in application security or networking, but future generation of security officers or whatever industry will be people from area, or there will be data analysts and machine learning specialists there. There will be key people for all industries. So I can really recommend to learn these techniques because this is the future. So I hope some of you will also help us to protect our customers in the future. Thank you.